Hello everyone. So yesterday we were discussing about operators and we have seen arithmetic operators, addition, subtraction, multiplication, division and modulus operators. Hope it is clear and I hope that it is you have understood what is an operator and what is the relevance of operator in the context of a programming language. Yesterday we have seen the example operators, yeah, addition, subtraction, multiplication, division and all we have seen example. Today we are moving on to another set of operators called relational operators, and in mathematics we have already encountered this. We have already studied these things. Less than or equal to. In mathematics we don't write this way. A line below this less than symbol is used normally, but such a key is not there in the keyboard, or such a character is not there in computer keyboard. So we use less than followed by equals, no space in between. Okay, remember that there is no space in between. Okay, less than or equal to, greater than or equal to, is equal to, is not equal to. This is for used for, these are all used for comparing data, especially numbers can be integers or floating point values. Okay, so relational operators, in many programs we will have situations where we need to compare two data values and take some decision or take some action, do some action. So in such case we will use this kind of operators to compare data. Okay, now when we compare two numbers, what are the two possible outcomes? Say 5 less than 6 or generally x less than y. What are the two possible outcomes? If I have something like x less than y, what are the two possible outcomes? X and y are two variables and I am putting a statement x less than y. Based on the value of x and y, there can be two possible outcomes, right? One is x less than y is true or not. Forget about what is there below. One is that this can be true. Other is that this can be false. And that depends on the value of x and value of y. If I simply write two constants, y 1 less than 2, it is obvious that this is true, right? 1 less than 2 is true. But when it comes to two variables, we don't know the values of x and y, so we cannot clearly say at this point of time, seeing the variables x less than y is true or false. So if they are constants, we could easily say 1 is less than 2, that is true, right? True. If I write 4 less than 5, what is the outcome? Or what is it true or false? This is true. 4 less than 2, false. So this is a relational expression, relational statement or relational expression, and there are only two outcomes possible. One is that the expression is true or results in true, or the expression results in false. So generally for a relational expression there are only two possible outcomes, true or false. That will depend on the values of x and y. Okay, so when we come here, for every relational expression, or a relational expression means say some variables or constants and with some operator applied on those. Okay, that's what an expression means. So every expression that involves any of the relational operators, there are only two possible outcomes. One is true and the other is false. And in C programming, true is represented by 1 and false is represented by 0. Okay. Any doubt? So we will see in what context we are going to apply. Then it will be more clear. So I'll take an example here, whatever example I have written here. I have two numbers x and y. Assume that you are taking the values from the user, but for simplicity I am directly assigning. And so we have two variables x and y, and we need to find which is larger. Assume that the two numbers are distinct numbers. Two variables are having distinct values, and my task is to find which is the larger among the two numbers. So in that case, we can apply relational operator to compare the values of the two values stored in the two variables. Okay. So how we are applying here is x less than y. Here is the expression, relational expression, x less than y. Now this will result in, I told, two possible outcomes. One at any point of time, only one outcome. Either it can be true or it can be false. Now if this is true, the program will execute this part. If this statement is true, the program will execute this part. And if this statement is false, that means this statement is giving 0 as the outcome, this part will be executed. So this is a practical application of relational expression in our program to find the larger of two distinct numbers. Okay, so whenever we take up relational operators, we have 6 of them: less than or equal to, greater than or equal to, is equal to or not equal to. Whenever the practical scenario of applying these operators is similar to this one. So this is one application, finding the larger of two numbers. Okay, and any relational expression, remember, it will result in two possible outcomes, either true or false, and true is represented by 1 and false is represented by 0. I will demonstrate that. So I have three variables: x is equal to 15, y is equal to 6, z I am not assigning any value. Three variables I created, and I am writing an expression z is equal to x less than y. This is the LHS, this is the RHS. Yesterday I told RHS will be completely executed and the final value will be assigned to the variable in LHS. Now x less than y is the right hand side expression, and that is going to be computed, and I told this will result in two outcomes only, either 1 or 0. If this expression is true, then it will result in 1. If this expression is false, it will result in 0. Now what will be the outcome of this expression, whether it is true or false? X is 15, y is 6. So when I am doing this, it's actually comparing 15 less than 6. 15 less than 6 is true or false?
False.
False. So this will result in 0, and that 0 will be assigned to z, and in the next statement I am printing the value of z, and we can see that it is 0. So one option we have seen, a relational expression resulting in 0 or false. Now I am going to change this slightly. Y is now 20. That means when I execute this, I am actually comparing 15 less than 20. 15 less than 20 is true. 15 is less than 20. 15 less than 20 is true. So what is the outcome of this RHS? It is 1. So my z should be assigned with 1. Okay. So I will compile and execute this program. I am getting the value of z as 1. So a relational expression results in two possible outcome, true or false. That means 1 or 0. And this is helping us to take decisions and perform some action based on the outcome of relational expression. Here I just showed the outcome of a relational expression, and in this example I am demonstrating how you can utilize to do some useful program. Here we are finding the larger of two numbers. Okay, larger of two numbers. So what we do is we put the relational expression within an if statement. If is a keyword to check for a condition and based on that take some action. We will learn about if soon in the next topic, but just to demonstrate, it is a simple statement. If in the brackets parenthesis you apply the relational expression, and if this expression is resulting in a true or 1, this part will be executed, otherwise the else part will be executed. It is like saying if sky is cloudy, you take umbrella when you are going out, otherwise don't take umbrella. Such a English like expression, English like statement, programmatically if we want to express, say here it's a mathematical problem. We want to compare two numbers and predict which is the larger one. We are applying relational expression. Okay. So similarly we can apply all the relational expressions here. So I can put x greater than y, or I can put x less than or equal to y, or x is equal to y, or x not is equal to y, and based on that my action will change. Okay, so all the 6 relational operators I can apply here, and based on that my action I have to slightly modify. When it is x less than y, I can directly, if it is true, I can say that y is larger, otherwise x is larger. I am assuming that x and y are two distinct numbers. Okay, this is a practical application of relational operators. So I have another example here. This one is age is the input. Age is the input. Here I am assigning a value of age directly to the variable age, but normally we will be taking as an input from the user, enter the age, and based on the value entered by the user, we have to tell the person whose age is given whether he is able to vote, eligible for voting or not, or he is an adult or minor, something like that. So age value, instead of since to keep the program simple, I am not taking the input from the user, but generally you have to take the input from the user. Some random age will be entered, and you have to tell the person can vote or not. Now here I am checking the condition, or using the relational operator greater than or equal to. I am checking age greater than or equal to 18. Now if that is true, this part will be executed, and if that is false, this part will be executed. In no point of time both of these will be executed. For a given input, either this or this will be executed based on the outcome of this relational expression. Okay, any doubt about relational operators? Basically used for comparing data, primarily numbers in the context of C programming. Numbers can be real numbers or integers. Any doubt? So two applications we have seen: finding larger of two numbers and checking whether a person can vote or not. So in both places we applied relational operators, and we combined it with some other statement, if statement, make some other mechanism in C language to conditionally execute some statement. So if is there, similar to English language only. If this is satisfied, you do something. If it is not satisfied, you do something else. If it is cloudy, you take umbrella, otherwise you don't take umbrella, like that. Clear? So 6 are there, and the functioning is similar. If you understand one, the functioning of others also very similar. Here you can check whether two numbers are equal or not. So if if x and y are having 5 as the value, x is equal to y is going to result in true. Okay, and x not equal to y will be false. 5 not equal to 5 is false. But 5 is equal to false is true. 5 is true. Like that. Is it clear? Relational operators. So I can say, I can take all of those probably if you want. I can, you tell me what will be the output. In each case you tell me what will be the output. In this case, what will be the output? False means 0. What I am checking here is 15 is equal to 20. It is false. We know that 15 is equal to 20 is false. Okay. Now I am going to change it to the other one. 1. Because I am checking 15 not equal to 20. 15 not equal to 20 is true. So Z will get the value 1. Okay. So to demonstrate that, I can show that Z is equal to 1. So if I check is equal to, this is going to give me 0. Because 15 is not equal to 15 is equal to 20 is false. So Z equal to 0. Okay. So practically you will apply in this kind of statements, this kind of programs, finding the larger of two numbers. Now we will move to another set of operators related to this relational operators. Relational operators are used for comparing two values so that we can take some decision or action, perform some action in our program. Okay, so they are used for decision making. If x less than y, you do something, else you do something else, something like that. So performing some action based on a condition, single condition, or you have checked only one condition, x less than y. But sometimes we will have to take decisions based on multiple conditions. Suppose we have three variables x, y and z, and we have to check x less than y and z greater than y. I have two conditions now, x less than y and say z greater than y. How do we take decision based on multiple conditions? Multiple conditions in our program. In real life we can do that. If what is that? Sky is cloudy and you don't have and there is no umbrella, carry your raincoat. So two conditions are there. Sky is cloudy and there is no umbrella. Then you take a raincoat. So conditions are sky is cloudy, whether it is cloudy or not, and there is no umbrella, there is umbrella or not. So these are the two conditions, and if when both are satisfied, you are going to take an action, carry raincoat. Like that, many times in programming also we will have to take decisions based on multiple conditions. If it is only single condition, one relational operator expression is enough. Okay. Now when we have decision to make based on multiple condition, there are some logical operators available. This will help us to take decision, especially the first two will help us to take decision based on multiple conditions, checking multiple conditions. Okay, so mainly logical operators are used for checking more than one condition to take decisions. Okay, now I'll show you a practical example so that you understand it better. Now I have two variables here, two variables, age and salary, two variables here, and based on the value of age as well as salary, I need to take a decision or make a conclusion. So what I am doing here is similar to previous statement. There are only one relational expression is there. Now I have two relational expressions. One here, age less than 30. That is one relational expression in the left hand side of the logical operator. And this is one logical operator. It's called logical AND. And in the right hand side of logical operator, logical AND, I have another relational expression, salary greater than 25,000. So based on two relational expressions or two conditions, I am going to take a decision here or make a conclusion here. So this is the action part if both are correct. If this expression, this condition as well as this condition is correct, this is the action I am going to take. And if that is not the case, this is the conclusion or action I am going to take. In such, here as I said, we are combining two conditions to make a decision. In such case, we use logical operators. So there are three logical operators: logical and, logical or, and logical not. Okay. So not is simply a negation of a decision. So it is a unary operator. There is only one operand for not. These two are binary operators. Binary operator means there will be two operands. One left hand side operand and right hand side operand. Addition is a binary operator because in left hand side there is a number, right hand side also there is a number. So it's called a binary operator. Whenever an operator is having only one operand, we call it as unary operator. So these two are binary operators and this is a unary operator. Okay. Now logical and example we have already seen. You have a left hand side expression. Normally it will be a relational expression. And right hand side also there is a relational expression. Logical and will the combined expression. This is the combined expression. Here is a relational expression. This is a here also there is another relational expression, and this the whole thing is a combined expression. Now, when this combined expression is true, this part is going to execute, and when this combined expression is resulting in false, this part or the else part is going to execute. This is like if the sky is cloudy and or as well as you don't have an umbrella, then when both these conditions are met, you are going to carry the raincoat you have left with. Okay. Otherwise, you decide probably you don't go out, something else, some other action. So in case of logical AND operator, if the left hand side is resulting in a true, at the same time right hand side also is resulting in a true, because this is then we are going to the combined expression is going to result in true. The combined expression means the whole thing is going to result in true. In that case, this action will be taken place. In all other case, this will be performed. Which are the other cases? When I have two relational expressions or two conditions to check, one case is both the conditions are true. This is true and this as well as true. In that case, we execute this or we take this action. What are the other possibilities? Can you tell me? Yeah, the left hand side expression can be true and the other is false. That is one case. Another case is this is false, left hand side is false, this is true. And the last case is this is false, then this is also false. Okay. Now true and true. This is the result of left hand side expression. This is the result of right hand side expression. If both are true, then the the combined result is true. That's what the overall expression is true. In that case only we are going to take this action. All the other cases, left hand side is false, right is true, or both are false, or this is true, this is false, this is false, this is true. All the three other cases, we are going to take this action. So the practical application of logical AND operator is to combine multiple decision statements or relational expressions, and logical AND works in such a way that If both the expressions, left hand side expression, relational expression, and right hand side relational expression, if both are true, this will be executed. In all other three combinations, this will be executed. So to represent this, we use something called as a truth table, in which case a logical AND operation is going to be true, and which are all the cases where the logical AND operation is going to result in false. That is called as the truth table of a logical operator. All the three operators are having a truth table. This will help us to identify or quickly recognize in which are all the cases where the combined or a logical AND logical AND operation is going to result in true, and which are the cases where it is going to result in false. So for logical AND operation, the syntax is like this. You have a expression in the left side followed by logical AND operator and followed by expression in the right side. So the truth table is like this. Expression in the left is 0. 0 means false. Okay. An expression in the right, that is also 0, resulting in 0. That means false. If both are false, this combined expression is going to be false. Then expression in left is false, right is non-zero. Non-zero, basically true is represented using 1. So far I told, but generally any non-zero value is also taken as true. 0 is taken as false. Any non-zero value, whether it is a negative number or a positive number, any non-zero value is generally taken as true. So instead of writing it as 1, I can generalize it as non-zero. Now my left expression is false, right expression is true. In that case, also the combined logical AND operation is resulting in false. Left is true, right is false, the resultant expression is still false. Left is true, right is also true, then only logical AND operation will result in true. Okay, so this is the truth table. Truth table is basically general representation of the behavior of a logical operator. Basically, in your electronics fundamentals, if you have electronics fundamentals, you will be learning this again. The truth table of there also logical AND operation is there, logical operation not operation is there, exclusive or etc. are there. We are taking only a subset of that: logical AND, logical OR, and logical NOT. Have you studied this in electronics already? Logical AND, logical OR, NOT, exclusive OR. Otherwise you will be learning. There also the same truth table you will study, but there it will be only one. But in the C programming context, any non-zero value can be treated as true. So I have generalized it, but for instead of non-zero, you will be seeing 1 in electronic fundamentals. Okay. So one voltage level for representing true, another voltage level for representing false or 0. One voltage level for representing 1 or true, another voltage level for representing 0 or false. Now we are dealing with programming. Same concept is applied. Okay. Any doubt regarding truth table of logical AND? Logical AND will be true only when both left hand side expression and as well as right hand side expressions are having true as the value. That means this. Now logical OR operator. Logical OR operator is represented by two vertical lines. You will get single vertical line in keyboard, normally above the enter key, and if you press shift and this, you will get two vertical lines without space in between. There is no space in between. This is logical OR operator. Okay, the behavior of logical operator is slightly different from logical AND operator. If they are same, we wouldn't have both operators. So in logical operator, if either left hand side expression or right hand side expression is true, then the entire expression will result in true. In logical AND, how it was? If both left hand side as well as right hand side, if both are true, then only the final expression will be true. But in case of logical OR, either of them only need to be true. So if this is true or this is true, the final expression is going to be true. Also, if both are true, the final expression is going to be true. When this final expression, the overall expression is going to be false, it is easy to remember that case. When this is going to be false, the overall expression is going to be false only if both left hand side as well as right hand side are false. Okay. So this should be true. When is it going to be false? When f left hand side is false, right hand side is false, it is going to result in false. In all other three combinations, left is true, right is true, it will be true. Left is false, right is true, it will be true. Left is true, right is false, then also it will be true. Only this is the condition where a logical OR operator is going to be false. In case of logical AND, in only one condition it is going to be true. When left as well as right both are true, then only it is going to be true. All other cases it is going to be false. Here only in this condition, logical OR operator, only in this condition the final outcome is going to be false. In all other cases, all other three cases, it is going to be true. Okay. So I have a example here. If age is a variable having some value, as of now it is 10, it can take any random value. If age less than 13 or age greater than 60, age less than 13 means a minor or a small child or age greater than 60, that means an elderly person. In either of these cases, that person need to be given special care. In all other scenarios, no need of special care. So such a decision I can take using OR operator. Either this is true or this is true. Either he is a minor or he is a senior elderly person. In that case, the action is same, needs special care. In all other scenario means the age from 14 to 59. Age from 14 to 59, they are relatively healthier and able to take care of themselves. So we say no need of special care. Okay. Any doubt? Any doubt? So we have truth table for logical OR operator also. Here both are false, outcome is false. Left hand expression, this is the syntax. You have expression 1 in left hand side, expression 2 in right hand side, and the logical OR operator. This is false, this is false. We have final outcome as false, and all other three combinations, the final outcome is going to be true. Okay, 0 and non-zero, 1. It will result in 1 only. Okay, not in non-zero. Don't be clear with that. It will result in 1. Even if the input one of the expression is a non-zero value and the other is 0, non-zero is treated as true, 0 is treated as false, the final outcome will be 1. Non-zero and 0, final outcome will be 1. 0, non-zero and non-zero, final outcome will be 1. That is what logical OR operator. Okay, so in real life, how can we express in plain English in our cloud and raincoat and umbrella case? If you have umbrella or you have raincoat, you can go out. In all other case, you don't go out. Something like that. Either you have umbrella or you have raincoat. You have a protective mechanism against rain, so you can go out. Okay. That's what the real world expression of OR. Then the final one, not operator. It is basically negation of, it's a unary operator. The syntax is like this: not of some expression. Okay, not of x, not of 0, not of 5. Now whenever I say an expression, it can be a constant. This is a very simple expression. Or it can be a variable, or it can be something like this, a statement like this, or it can be a statement like this, or it can be a complex statement like this. Okay, whenever I say expression, all these are expressions. This is a very simple constant expression, this is a variable expression, this is a relational expression, this is an arithmetic expression, this is a compound arithmetic expression. So all these are expressions only. Okay, so you can apply not operator on an expression and it will simply negate the value of that expression. So if the value of that expression is true, you will get not of x will be 0 or false, or not of 0. 0 is false, so not of 0 will be 1. Not of 5. Not of 5 is an expression, constant expression, and it's a non-zero value. Non-zero value is treated as true, so not of 5 will be resulting in 0, which is false. Not of x greater than 5. X greater than 5 will result in either true or false, or 1 or 0. If this is resulting in 1, not of 1 will be 0. If this is resulting in 0, not of 0 will be 1. So the truth table is, you have only one input, one operand for not expression, not operator. So if it is non-zero, you get 0. If it is 0, you get 1. This is the truth table for not operator. So basically it is used for negation of the existing value of the expression. Not is used for simply negating. Non-zero will be negated to result in 0, and 0 will be negated to result in 1. Okay. So we have something here, but I don't think we have time to do that. We will, or what time we have till? Until what time we have? 12:40? 12:30. Till what time we have class today? Okay, 12:40. So we have some more time. Okay, thank God. Good. I got little confused with the time. Okay, 11:50. Okay, we should have started at 11:50. I was thinking like we should start with 11:40. Anyway, we have time there. Okay, even I think teacher madam did not exceed at the time. I was thinking we should start at 11:40. Okay, so we have time to complete this example. So did you have any? Do you have any doubt regarding these operators? Anyone with a doubt? Please ask. So I have an example here. Int a is equal to 10, a less than 18. That is effectively 10 less than 18. 10 less than 18 is going to be true. So the outcome of this result or outcome of this expression will be 1. 10 less than 18. Now if I apply not of 10 less than 18 or not of a less than 18, the output will be 0. Okay. So normally used in decision making. So not of age less than 18. Not of age less than 18. That means the person can vote. Age less than 18, if it is true, is a minor. So not of age, so in this case what will happen, age is, suppose age is 10, age is 10, 10 less than 18 is true. That means he is a minor. 10 less than 18 is true. and we get 0. I mean 1. Now not of that is 0. Not of that is 0. My if expression will execute that statement under that only if this whole thing is resulting in 1. So when age is equal to 10, age less than 10 is 10 less than 18 is true. That means not of that is false or 0. So we get if 0 and this will not be executed. Okay. Now age is 25. 25 less than 18 is false. Not of that is true. That means we get if 1 as the overall expression. In that case, the person can vote. So that is the usage of not operator. Now there is an equivalency. Instead of using not of age less than 18, can I use it in a different way? This is a little negative logic. I am using not of age less than 18. Can I find an equivalent simple expression? Equivalent simple expression. Instead of writing not of age less than 18, what I want to find is whether based on the age the person can vote or not. What if I write age greater than or equal to 18? I get the same outcome, right? Yes. So effectively, when we write it this way, we call it as a negative logic. Negative logic. In a roundabout manner, we are trying to achieve something. So this can be put in a different way or equivalent way, say, or same effect. Equivalent way if I am putting age greater than or equal to 18. Okay, so that's what this statement means. Not of age less than 18 is equivalent to putting age greater than or equal to 18. Either can be used in a program. So you can use it in either of this form, either of the forms in a program. But preferably, optimistically, we will use this. So it is easy to understand also rather than going for not of age less than 18. But there are some other scenarios you will have to use not operator. In this case, we can go with the positive logic instead of like checking for not age less than 18 in brackets. Okay, not because this has to take place first. That's why we are putting it in bracket. So in just like mathematics, if you put it in bracket, that will be executed first. On the result of this, not will be applied. So instead of using this, we can use this positive logic, but effect is same. Okay, there is no difference in the outcome. So these are the three logical operators, and today we have seen relational operators, 6 relational operators used for comparing data values. Then so that we can practically take some decision or take some action based on the comparison of values. An application is finding larger of 2 numbers or largest of 3 numbers, etc. We can apply this relational operators to find the largest of 3 numbers or n numbers or 2 numbers. Then we have logical operators, logical and, logical or, and not operator. Mainly these are used for combining multiple conditions to take a decision. Okay. And we have seen the truth table of each of them. Go through the notes, and I will also upload the video. I keep uploading the videos of every class in that drive, Google Drive. You can watch that if you did not understand, and you can come back to me whenever you find stuck with these topics. Okay, then we'll stop for the day. See you in the next class. Thank you.